Hello. Today I'm just going to talk a little bit about electron orbitals. And when I say electron orbitals, these are the places that we're going to find electrons. We know in our nucleus, we've talked about that, our nucleus has protons and neutrons. Well, let's start with some of the properties of electrons. And I'm not going to get into a great amount of detail here, just touching on a few things. Electrons have wave-like and particle-like properties. Now, if we expected them to be like protons and neutrons, they'd be more like particles. But they also behave like light waves, and they have wave-like properties. We're going to start getting into, or this gets into, I won't get into it, but this gets into like the quantum theory. And what I said before is that means that electrons don't act the same as protons and neutrons. They're just different. Now, when we are talking about where electrons will be on the outside of an atom, so here's our atom nucleus, and then there's electrons going around it. That 3D space or region that we find electrons in is called an orbital. Now, this does not look like Saturn, where the rings of Saturn are in a nice even plane going around Saturn. It's different. But what we do find is that as you increase an orbital, so there's multiple orbitals, there's multiple places where you'll find electrons, the energy increases as you move away from the nucleus. And we see that right here. Here's our nucleus. As we move away, the energy is increasing as we do that. Okay? Now, the different energy levels that we have for an atom, those are called principal quantum numbers. Again, we're getting into the quantum realm here and things get weird. They're just different from our daily experience of the world around us. But sticking with this idea of orbitals and electrons and where you find them, let's go on to this next page. So another name for the principal quantum numbers are electron shells. So electron shells, that's what you see here. See, it says electron shells, and then it has 1 level, 2 levels, 3 levels, 4 levels. Again, with the nucleus being in the middle. Multiple electrons can fit in any particular shell. So this red circle right here could have 2 electrons in it. And as we go up, each shell can hold more and more electrons. 2 is going to be the minimum. So even the smallest shell can hold at least 2, so multiple electrons. And then if you see as we go up in electron shells, the higher the shell level, the more electrons will fit. Right? This first shell level can hold up to 2. The fourth one can hold quite a bit more. Each of these dots represents 2 electrons. So you're talking many, many electrons that fit in this shell and only 2 that can fit here. Again, we're just trying to cover a very basic idea here. You can get very detailed in this if you want. All right, let's go down to the bottom here. Electron orbitals can be found in different shapes. We see a sphere here, and these are 3-dimensional shapes. There's kind of this 3-dimensional figure 8, and then there's another 3-dimensional, I don't know what to call it, multi-figure 8, flower arrangement. So electron orbitals can be found in different shapes and sizes. The different shapes and sizes are all based on an interaction between the electrons and the positively charged nucleus. So as you get more and more electrons on an atom, those electrons will be found in different shells or different orbitals around the nucleus. And there's this complex interaction that's going on. So you might have a couple that are in a shell like this sphere. And then you might have several more that are in this kind of figure eight 3D shell. And it's important to remember this is just the probable location of an electron. So when we talk about these orbitals and these shells, we say that the electron could be found anywhere in there. And then finding the exact location of the electron gets a little tricky. And that's when you get into more of the ideas of quantum physics. All right, well, I hope this helps at least a little bit. Thank you.